In this lecture we are now going to learn about collisions. Okay, so we have learned about hashing, hash table. Now how to remove collisions or handle collisions basically. So how to handle collisions. So this is your hash table. Let's say I take one hash of x as x square mod 10. Okay, so we take this example and our inputs are basically I take x, which is from the set 1 2 3 4 till 9. Okay, so let's see what happens. So h of 1 will be 1 square modulo 10, so it will be 1. So h of 1 will come basically here. Okay, h of 2 will be 2 square modulo 10, so it will be 4, so it will come here. So 2 will come here. H of 3 will be 9 square, okay, 3 square, so 9, 3 will come here. H of 4 will be 4 square modulo 10, so 16, it will come here. And then you have h of 5, which is 5 square, 25 modulo 10, so it will come here. H of 6 will be 36 modulo 10, so 6 will also come here, and here we encounter collision. Okay, so this will be there if you have a hash table where you are using such kind of formula. So h of x, there is chance for h of x to be equal to h of y, and then there will be collision. So h of 7 will be now what, 49 mod 10, so h of 7 will come here. Okay, h of 8 will be 64 modulo 10, so it will be 4, and 8 will come here. Then what happens, h of 9 finally 81 modulo 10, so it's 1, so it will come here, so 9. Okay, this is nothing. So here you see, in fact there were 9 elements and we had 9 cells, but the thing is, because we are using some hash function, there were collisions, and in fact 1 2 3 4 collisions were there. Now the thing is how to handle these collisions. There must be some ways, and in fact you have to handle it for a hash table to be useful. Okay, so what do we do? So one idea, in fact the first idea is that is known as separate chaining. Okay, so what is separate chaining? The idea is to keep a list of all elements that hash to the same value. Okay, so we will keep a list of elements, okay, that all hash. So like here, these will all go into a linked list. Okay, so this 4 will maintain a pointer to a linked list which will have all the elements that are hashing to this particular cell. So array elements are pointers to the first node of the list. So these are linked lists, and your array, okay, element has the pointer to that linked list. A new item is then inserted. Now we said that insertion is O of 1, so you have a linked list here, and what you do, just insert at the head. Okay, so this is again O of 1. In linked list, insertion in the front is O of 1. So that's fine. But again, I think you will say that okay, insertion is fine, but what will happen to deletion? You cannot guarantee that whatever I am trying to search will always be in the front. In fact, search will also not be O of 1. Now it will have something else. I have to traverse this list. I can find h of x where that linked list head is, but then I have to traverse that list. Okay, so what are the advantages? Any advantages? So better space utilization for large items. Okay, simple collision handling. I'm able to handle collision. If I was just doing that, okay, hash table, let's say ht was the hash table and h of x is equal to x, it will overwrite it and I cannot have something more than 1. So simple collision handling, searching linked list. Overflow, we can store more items than the hash table size, of course, because now the hash table size, I can have the linked list there and I can store more. Deletion is quick and easy, deletion from the linked list. Okay, so this is the example, and they are in fact doing the same thing. From 0 to 9 they are doing. Okay, and they are again using the hash of x is equal to x modulo 10. So 0, okay, so 0 mod of 10 is 0, and your key, in fact they're using what? So this one is key, so 1 will be inserted first. Okay, because 1 modulo 10 is 1, and then we have 4 is the next input. 4 modulo 10 will be 4, it will go into this linked list. Okay, and then 9 will go, 9 modulo 10, 9 will come here, 16 will go into 6, 25 will come into 5, 36 will again come here, and initially 16 was there, now this will become the front 36. 49 comes here and it will push 9 forward, 64 will push 4 forward, and 81 will push 1 forward. So this is the case. This is your hash table. These are containing, these hash table contains the pointers for these linked list. Now you can handle collisions, but the thing is we have got linked lists in each of those cells. So how to analyze this? Now again, as we said, this is the load factor, ratio of the number of elements n in the hash table divided by the table size. Okay, so that average length of the list, then we can expect that should be lambda. Okay, the number of elements by table size, and of course for chaining it can become greater than 1, isn't it? So for example, if your hash size is just 10 and I have number of elements equal to 100, so of course in each list on an average, if for random inputs, you can assume it to have 10 elements each in your linked list. So this is the case, and what will happen? Now the thing is, what will be the cost of insertion? So insertion is still O1, isn't it? And you have search. So what will be the cost? First will be h of x I need to find, then I will get the pointer to the linked list where my element will be there. So that linked list has length lambda on an average. So your search will now become the time for calculating h of x plus calculating traversing this list, which can be O of lambda in the worst case. Okay, so this will be there, and your deletion also, basically you have to traverse this linked list. So this is the for separate chaining. And now someone asked that, okay, what is it really useful? So what are the problems? So of course the problem is, this is not a simple data structure now, it has two data structures now. Basically we have an array of pointers, and each pointer is now having a linked list. Okay, so this has become an array of linked list also. So this is not that simple, and in fact, so we have some extra memory we have to use, which is greater than the table size, and so on. So we will in our next lecture look at some other ways of storing the elements, but this one is first way of handling collisions in your hash table. So I hope you understand this. Thanks a lot.